Sometimes when we're solving by completing the square, we have a little bit of an added piece of difficulty when the value of b, the number in front of the x, is odd. And the reason that's problematic is because of how we come up with the number that will complete the square for us. So recall the first thing that we want to do is we want to isolate the x pieces. So I want to move all the integers to the other side if there are any. So I've got x squared plus 5x equals 5. So I'm leaving that space so that I can fill it with the number that will complete the square for me. And so the way we come up with that number is b divided by 2 squared, where b is the coefficient in front of the x. And so in this case, that coefficient is 5. So when I take 5 and divide it by 2, it doesn't divide in evenly. Now we might be tempted to go ahead and push buttons on our calculator and just make that 2.5 and then square that. But really it's in our interest, and what we're going to do here is to leave it in fraction form. So I'm just going to square this, and so I'm going to square the top number and the bottom number. So I'm going to get 25 over 4. So that's what I'm going to add to both sides of my equation. So I'm going to add 25 fourths to both sides. So now I have to add these two numbers over here on this side, so I need to get a common denominator in order to add those. So we need to multiply the top and bottom of 5 over 1 by 4. So I'm going to get 20 over 4 plus 25 over 4. Now on the other side, we have to factor that expression. Now we don't have a whole lot of experience factoring expressions that have a fraction as that last number. But because of how we came up with this number, this 25 fourths that we added to both sides, we still know that it's going to factor into x and then the same thing twice. And the pattern is always it's x and then plus half of b before you square it. And so that was this right here. We took 5 and divided it by 2, and we just left it as 5 halves. So that's going to be the number that I'm going to have here when I factor it. So it's going to be x plus 5 over 2, x plus whatever b is divided by 2 squared. So now on this other side, I'm going to go ahead and just add these two fractions. Now remember, when we add fractions, the 4 stays the same in the denominator there. It's just the numerators that we're going to add. So 20 plus 25 makes 45. Over here we still have x plus 5 halves squared. So now at this point we're ready to go ahead and take the square root of both sides. And so on the left hand side, the square and the square root cancel each other out. So I'm just left with x plus 5 halves. On the other side, I'm going to take the square root of the top and the bottom separately. So the square root of 4 is 2. And then in the numerator, I'm taking the square root of 45. And if I factor tree that, I'm going to get 9, and 5. And 9 is a perfect square, so I'm going to replace that with a 3. So I still need my plus or minus, so I've got plus or minus 3 times the square root of 5. And so then our last step, as grim as things are looking, is to subtract this 5 halves from both sides. I have to get x all by itself. But if you'll notice, we have the same thing in both denominators. So if I scroll down here just to leave us a little bit more space, I'm ending up with just x isolated, which is what I want. And then on this other side, since I have the same denominator in both of the fractions here that I'm trying to combine, I'm just going to make it a giant fraction with a 2 on the bottom. And then in the numerator, I'm just going to have the two numerators connected by that plus or minus. I'm going to have negative 5 plus or minus 3 times the square root of 5. And so we end up with this answer that is in this fraction form because of that odd value in front of the x. But if we just follow our process of finding the number that we have to add to both sides by using that b over 2 squared, then factoring it, knowing that it always factors into x, and then the second piece being whatever half of b is, so in this case 5 halves. And then if we just continue with that same process where we take the square root of both sides and then we isolate the x, we'll still get to the answer the same way that we do when that coefficient in front of the x is even. We just have to carry these fractions through the problem. So we'll approach this next one the same way. I'm first going to isolate the x's, so I'm going to add 4 to both sides. So that leaves me with x squared minus x equals 4. So now I have to come up with the number that's going to complete the square. What am I going to add to both sides? Now it's important for us to recognize that the number in front of the x there is -1. So I'm going to take -1, I'm going to divide it by 2, and then I'm going to square it. So when I take that and square it, -1/2 times -1/2 is going to give me a positive 1/4. So I'm going to go ahead and add 1/4 to both sides of my equation. So on this other side here, I've got to get a common denominator between those two in order to be able to add those. So again, I'm going to multiply by 4 on the top and bottom. So I'm going to get 16/4 plus 1/4. And then on the other side, I'm going to factor it the same way that we did before and when it's an even number. I'm going to have x. I know it's going to factor into the same thing twice. That's because of how we came up with the number we added to both sides. And then it's going to be half of the b number before I square it. So half of -1 is -1/2. And we can see that right here as well. So it's going to be -1/2. So over on the right hand side, I'm going to add these two fractions together. Denominator stays the same. 16 plus 1 is 17. On the other side, I still have this x minus 1/2 squared. So now I'm going to take the square root of both sides. So on the left side, the square and the square root cancel each other out. So I'm left with x minus 1/2. On the other side, I'm going to take the square root of the top and the bottom separately. So the square root of 4 is 2. So hopefully we're seeing that it's working out similarly to the previous example. Up in the top, I can't simplify the square root of 17 at all. So I'm just going to leave it as plus or minus the square root of 17. And then my last step is to get the x all by itself. So I'm going to add 1/2 to both sides. So I'm left with x equals, and then once more, I've got the same denominator in both of the fractions. So I'm just going to make this a giant fraction with 2 on the bottom. And then in the numerator, I'll just put the two pieces together, 1 plus or minus the square root of 17. Oops, let's try to write that a little better. 1 plus or minus the square root of 17.